So as we continue on in Chapter 8, we are now solving quadratic equations that can be solved by using square roots. Okay, so again, just like yesterday, not all quadratic functions are factorable. So not all quadratic functions can be solved by factoring. Not all quadratic functions can be solved by using square roots, but sometimes they can. Okay? And we'll discover, we'll kind of maybe narrow it down and say, oh, this might possibly be the times that we could. So when b is equal to 0, well, it's kind of sounding like that's one of the conditions. If b is equal to 0, it's probably one that you can use this method for. So what we'll do is we'll set the ax squared equal to the c term, because there won't be a bx term. Remember, b is going to be 0, so 0 times x would wipe those guys out. So we'll set the ax squared term on one side of the equation and the c on the other. We'll divide both sides of the equation by the a value, especially when it's not a perfect square. And then we will take the square root of both sides. Square root meaning what?
What times itself?
Yeah, what's the factor that if you multiply it by itself will get you the square that you started with, okay? So let's just go right to practicing here. We have number 1, x squared equals 25. Is there a, what's our b value in this one? 0, okay? What is our c value? If this was written in standard form, set equal to y or set equal to 0, what would the c value actually be? 25. No.
Wait.
Because remember, if this was not already set up like this for us, wouldn't it have in standard form started like this?
Yeah.
Wouldn't that be its standard form name? Okay. So the c value is actually what? Negative 25. Okay, so we're going to take the c value and move it over to the other side. So yes, it's kind of confusing when it says set it equal to the c value. Maybe it should say move the c value to the other side of the equation. That might be a little bit more appropriate. Well, this one's already ax squared set equal to the constant on the other side. So it says now we can divide both sides by a. Well, what's our a value? 1. Is it going to do us any good to divide by 1? No. So we get to go directly to taking the square root of each side. And what would that be? X equals 5?
Yeah. No. Yeah.
X equals 5.
Okay, let's go put it in our graphing calculators. Let's see if we're right. So this, if there's only one solution, then that would mean the vertex is where? On the x-axis. Okay. Would you go to y equals, clear out anything that's in there, and would you type in x squared minus 25? We have to do it the way it was in standard form before it was set equal to the 25. So x squared minus 25. Do a zoom 6. We just really want to zero in and see the solution or solutions. Is the vertex sitting on the x-axis?
No.
No. So then it's above the x-axis?
No.
No. Okay. Well, then it's crossing the x-axis twice.
Yeah.
Well, if it's crossing the x-axis twice, that means what?
2, 0. No.
Yeah, 2 zeros, 2 solutions, doesn't it? Okay, what do you think the other solution is then, looking at the graph? Or go to the table if you have to.
5 and negative.
5 and negative 5. So when we're taking the square root of 25, 5 times 5 is 25, right? But is negative 5 times negative 5 also 25?
Yes.
Yes. So we have to account for the fact, and here's the shortcut way of writing it. Instead of having to write x equals positive 5 and x equals negative 5, we can shortcut it and say, oh, we have a positive and a negative 5. That's what that sign in front of the 5 shows, that there are actually, let's circle that, and let's write right here, there are 2 solutions. I still don't want you to think this only means one solution, because it is crossing the x-axis at both of those locations, right? Okay, tell me something. Why should this make sense to us, that this is almost like a shortcut way of finding the solutions for this? Why should this make sense to us though, that x squared minus 25 would have those two solutions? Tell me something about x squared minus 25. What is that? It's one of those special products, isn't it? In fact, it's the one called what?
Difference of squares.
Difference of squares. And do you remember how we shortcut finding the factors for the difference of squares? How do we factor this?
Just find the square root.
Find the square root of each of the terms, right? And then what do we do?
Since it's a subtract 5, it'd be, or subtract 5 would be x plus 5 and times x minus 5.
Yeah. Difference of squares is not a binomial times itself, but instead it is they both start with the square root of the first term, they both end with the square root of the last term. One has addition, one has subtraction, because we need the what term to cancel out? The bx term, right?
Yeah.
Yeah. We need our O and our I step of FOIL to cancel out, and there was no x term in this one, was there? So if we would set each of these equal to 0 and now solve them, x plus 5 equals 0, would that one be our negative 5 right there? And if we would, so there's one of the solutions, and if we would set the x minus 5 equal to 0 like we were doing yesterday, 0 product property, and this one, it would give us the positive 5. Well, it was a whole lot less work to do what we did, wasn't it? First time. So when b is 0, take this shortcut. Don't go through all that work we just did over on the side, but recognize it's really the same thing, okay? So here's where students typically make their mistake when they're using the square root method. They forget about that there are two square roots for things, a positive square root and a negative. Because two positives multiplied make a positive, two negatives multiplied make a positive. Yes?
Will it be like that most of the time?
Will it be like that most of the time when you're being
Will it
like?
be a negative and a positive?
Yeah. It will. Okay. Any other questions? Okay, so only one time are we going to go through all this work that I just did over here. I just wanted you to see that we can really factor. We could also solve x squared minus 25 equals 0 by factoring. We would do what we just did I did over there in the margin, and we would get the same solutions. But today we're saying, you know what, if b is equal to 0, take the shortcut. Okay, number 2. 5x squared equals 245. The x squared term is on one side, the constant is on the other. So we can kind of skip that first step. What's the next step say to do? No? Divide by a. So we're going to divide both sides by the a value, which is what? 5. Because it really actually makes your life a little easier. Well, there is another way to solve it, and I'll show it to you in a little bit. But okay, and then we get x squared over here. And what do we get on the other side? 49. 49? Well, what do you know? 49 is a what? Perfect square. So when we now take the square root of x squared and we take the square root of 49, we're going to get
X equals 7.
equals
Negative 7.
Negative. Oh yeah, that positive negative. There are two square roots. There are two of them. Now, we should get positive negative 7 no matter how we solve this. But tell me something about 5 and 245.
That factor for GCF.
You can GCF them? Okay, well when we GCF though, that doesn't, well it kind of does. It's kind of like if we're GCF and we would GCF both sides, we divide a 5 out of both sides, right?
Yeah.
Which is kind of what we did when we divided by 5. But are 5 and 245 perfect squares? Would it have been a good idea to do this? The square root of 5x squared, square root of 245. Would that have worked very well? Go ahead and take the square root of 245 in your calculator. What do you get? Is it a nice number? Or does it kind of look like it's got a whole bunch of stuff going on after the decimal point? Do you not know how to use the square root key in your calculators? Do you know how? Yeah, anybody need help? Oh,
Yeah,
yeah?
I forgot because we learned it at the beginning.
Okay, so this key leaves you'll do second squared and take the 245. Press enter. Oh, did you guys give it as a radical answer? 7 square roots of 5, like Pat's did? Okay, anybody get it in decimal name? Yeah, okay, what does it look like in a decimal name? Oh my, you should see AJ's here, 15.65247584. Poof, it does not look like there's gonna be a repeating pattern even. So, 245, the square root of 245 is what we call an irrational number. But now, if you would do this, will you do this for me? Will you take the square root of 245 and divide it by the square root of 5?
So,
Hi, you get 7, don't you? Yeah. Okay. So, we have two choices here. If we're going to do that, then we would almost have to say, I'm going to divide each side by the square root of 5x squared. You know, it would kind of almost feel like we're not getting nowhere with it. So let's just do the suggested divide by 8. I think it'll be a lot easier. Okay, let's do number, oh, by the way, let's graph that one. Let's curious to see if it's actually the right solutions. So in y equals, put 5x squared minus 245, because that 245 has to be over there with the x squared term. So 5x squared minus 245.
Straight or
And just press graph, just graph from this point up. Does it appear to be crossing the x-axis at 7 and -7?
oh yeah.
Oh yeah, you know, you're seeing like this at the problem, aren't you? You can't see the vertex, you can't see the y-intercept. In fact, what would the y-intercept be? No?
No.
245. That would be, it would be negative 245. So it's way, way, way down there. You can't see it, can you? And where would the vertex be? What would the y value of the vertex have to be? Less than negative 245. Because if it's crossing the y-axis at negative 245, the vertex has got to be even below that, doesn't it? Yeah. So, but right now what we want to see is where is it crossing the x-axis, because those are our solutions. Okay? Okay, now turn those off a little bit. Let's go from here now. Okay, what do you suggest we do in number 3? Okay, why do you want to add 64x squared, Kevin?
well, because you want one on one side of
You want them
the other.
separated,
Yeah.
okay.
Yeah.
Well, why can't we move the 9 over instead?
You
Want to
could,
get
but
rid of
it'd be easier to keep a positive 6.
Yeah.
Can you tell me why it would be nicer to have a positive 64x squared?
I guess no, because we're going to get a positive and a negative answer.
Yeah, but would you try something on your calculators? Is 64 perfect square? Yeah. Okay, would you take the square root of a negative 64? This is, you know, when I say on your calculators, I mean using yours. Error. Why?
Wow.
You don't know. Oh, you.
Yeah, so don't make an error.
We should throw these calculators away then. There's got to be a reason why it's going into
Because you
error.
can't take a negative 8 times a positive 8, because I'm not allowed to do this.
There is no square.
Yeah.
There is nothing times itself that'll give you negative 64, is there? No. So we can't take the square root of a negative number. So I kind of like Devin's idea that, you know what, we need a positive number. So let's make this 9 equals 64x squared. Let's move the 64x squared over instead of the 9. Now tell me something about 9 and 64.
Perfect square.
They're both perfect squares, aren't they? So we actually have, in this one, you could go about this one 2 different ways. So let's do the first way, which the directions say divide both sides by 8. Let's do that way first, okay? So divide both sides by 8. We're going to divide both sides by? No, that's not our 8. I know, we'd might rather divide by 9. but we're gonna divide by 64. Okay, well then, x squared is equal to, 9 divided by 64, is that nice?
No, 0,
Zero, blah, 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 okay, so, guess what we're gonna do? We're gonna leave it a fraction. Is there anything that goes into 9 that goes into 64? Oh, you know what? I don't even care if there is, because I don't want to mess with these guys. They're both perfect squares. Because when I take the square root now of both sides, like our next step says to do, we really are looking for, well, what times itself is x squared? That's x. We're really looking for what number, what fraction times itself gives us 9/64. 3/8, right? Because the square root of 9 is 3, and the square root of 64 is 8. Or in other words, this could really be separated like this, give them each their own square root symbol. You can do that. Square root of 9 is 3, square root of 64 is 8. Is there only one solution for this?
No.
Positive and negative 3/8. This would cross the x-axis at both of those locations. I'm guessing this is a pretty skinny parabola. We gotta graph this one just to see it. So we're gonna do 9 minus 64x squared. It's already in standard form there. You can put it in just like that though, in your y equals 9 minus 64x squared.
Whoa.
Is that one skinny parabola? Remember what we said the a value does? Not only does it tell you which direction it opens, but it also, which you can't even tell what direction it opens, can you?
No.
It looks like going
Well, it's
down.
gonna be going down because it's a negative.
Yeah, because it's a negative 64, so it's going to be going down, but remember the larger the absolute value of a, that's also going to make it skinnier and skinnier and skinnier, because, and that makes sense, doesn't it, because it's crossing the x-axis at numbers less than 1, right, or greater than negative 1. Okay, turn those off one more time. Okay, what do you suppose we got to do in this one, number 4? Subtract 3, okay. In other words,
Combine my terms.
yeah, combine like terms or get the x squared by itself to start with.
Yeah.
Or could we, wait a minute, but we do want the constant on one side, don't we, and the x squared on the other in this one. Yeah, so this would be a good move, wouldn't it? 25x squared, now the x squared would be alone, and the constant would be 121. I like that move. Okay, now what?
Combine my 25.
Divide by 25. Now, I'm going to show you something though. I'm going to show you a different way. When they're both perfect squares, is 25x squared a perfect square?
Yes.
Yes.
Is 121 a perfect square?
Yes.
It is.
Yes.
Yeah, okay. So instead of us dividing by the a, when they're both perfect squares, hear that, very plain and clear. When they're both perfect squares, you can go right to this. Because what is the square root of 25x squared? 5x. Now, only one side has to be made a positive and a negative, not both of them. Okay? So, what's the square root of 121? A positive and a negative 11, right? Okay. And now what would we do? Because of course we would divide both sides by 5. We can't leave it 5x. We have to get it just x. So we have this positive or a negative 11 divided by 5. Our solutions are, is 5 11/5?
No.
Okay, it's not an integer, is it? No. How about, is it a nice decimal? Yeah, it's a nice decimal. So we could give it its decimal name, or we could leave it as its fraction name. Typically, you probably would see in an answer key it left just like this, typically. Okay? Now, we would have used the dividing by a method first. Would we have gotten the same answer?
You should.
We should, yeah. You can watch me check it out here. I would take both sides divided by 25. So I'm just going to do this here. And that will give me an x squared equal to a 121 over 25.
Yeah, you're
Square root. Square root. What's the square root of 121? 11, what's the square root of 25? 5. Guess what? We get the same answer, don't we? Yeah. So you can go, when you have perfect squares on both sides, you can do it the way we did it, or you could stick with the plan of dividing by a and then taking the square root. Okay? Questions on these? These were all perfect square ones, so they have nice, rational square roots, in other words. Okay, let's go to the back side. Okay, so sometimes the number you're going to find the square root of is not a perfect square. Not all numbers are. Can you give me an example of a number that's not a perfect square?
5.
5. Are there lots of not perfect squares? Yeah, there's a whole bunch of them. So when we have a number that we're trying to find the square root of that is not a perfect square, we are going to do two different things with it. We're going to learn how, and your calculators are doing it for you, which, kind of disappoints me, but that's okay. We're going to leave it in a simplified radical form answer. For the exact answer, that one's called. That's called the exact. No rounding has been done. This is what its exact answer is. So when Kat, I think, got 7 square roots of 5, and some of the rest of you said you got the same thing, that would be called leaving it in simplified radical form. Because 5 is not a perfect square, and we can't take the square root of, we cannot divide 5 by any number that will divide out that is a perfect square out of 5, other than 1, so that's as good as it gets. Or we're going to round to the nearest hundredth, that's what we're going to, so that we're all rounding to the same thing, for the rounded answer, the estimated answer. I don't want to call it estimated, because estimated usually means just kind of like us looking at it and saying, I think this is what it should be. Okay, so let's take a look at the first one we have here. 3x squared equals 81. What's true about 3x squared? Perfect square or no? No. How about 81?
Yeah.
It is, but that's not going to do us any good. They both have to be, don't they? Yeah, so we'll still do the same thing, though. We have the x squared set equal to the constant. We will still take each side and divide it by the a. And what will end up happening is, if anybody remembers, 3 to the 3rd power is 81, right? Or 3 to the 4th power, is 81. So 3 goes in there 27 times, because 3 to the 3rd power is 27. All that ends up happening is now the square term becomes a perfect square, and the other side's not a perfect square. But that doesn't matter. We're going to, we're going to take the square root of x squared, and we're going to take the square root of 27. Now, to give the simplified radical form, that means, and I really want you to be able to do this without your calculator doing it for you. You're going to have to know how to do this next year in geometry. So, are there any perfect squares that divide into 27? Even though 27 isn't a perfect square, does it have any perfect square factors? Okay, what is 9? Okay, so this could be renamed as, so we're going to have x equals a positive or negative. Once we take the square root, we have that positive and that negative. We're going to rename it as the square root of 9 times the square root of 3. We can break it apart, give each of those factors of 27 their own radical sign. Because would you take the square root of 27 right now on your calculators, please? We're going to do it again in a little bit. You know what, we might as well right now just do the approximate answer down here then. So let's go down to the bottom here. We're going to write the approximate answer when you're finding the square root of 27 right now. Round it to the nearest hundredth. Square root of 27, round it to the nearest hundredth. That means you're going to look 3 decimal places behind, because the third one behind the second one is going to decide if the second one should round up. So right now, when you are on there, you should be able to say that the square root of 27 is 5 and .196.
Mine doesn't give a decimal.
Oh, you guys are gonna want it to give it, so we're gonna have to figure out how to change it a little bit here. So right now, here's what my calculator says. I'll show you. Mine says 5.196. So if I'm supposed to round that to the nearest hundredth, right now it's 19 hundredths, isn't it? Is that 6 big enough to make it 20 hundredths?
Yes.
Yes. So we're gonna round that to 20 hundredths. And we're going to show the 0. We're going to show that it's 20 hundredths, not 2/10. So this is our approximate answer. That's one of our answers. This is the rounded answer. So that's why you use the squiggly equal sign. Approximately equal to. And then we're going to go back up and give it simplified radical name also. So there are not going to be 4 solutions. That is not what I'm saying. I'm saying that we're giving the 2 solutions in rounded answer form, and we're giving the other one in simplified radical form. The rounded gives us a general idea of where the parabola would be crossing the x-axis. It'd be crossing the x-axis at approximately a negative 5 and 20 hundredths and a positive 5 and 20 hundredths. Okay, now I want you to do this with your calculators. I want you to take the square root of 9 times the square root of 3. Multiply it just like that, the square root of 9 times the square root of 3. However your calculator is giving it to you, you get the same thing as if you took the square root of 27. When you took the square root of 27, and now you took the square root of 9 times the square root of 3, did you get the same answer? You should. Okay. So that means all we're doing is renaming the square root of 27 as the square root of 9 times the square root of 3. Tell me, what is the square root of 9? 3. We can actually take the square root of 9, so we can eliminate the radical sign. The square root of 9 is 3. No more radical. How about the square root of 3? Is that a perfect square? No. Are there any perfect squares that divide out of 3? Any perfect squares that divide out of 3? 1. Is that going to get us anywhere? No. Okay, so that means the square root of 3 has to stay the square root of 3, and we can ditch the multiplication sign. And I'm guessing that's how your calculators, those of you who it's given it to you in radical form, how it's showing you, isn't it? Yeah. So this is the exact, we would call it. This one right here is the exact.
Is it going to ask for both?
Yep, I want you doing both. The exact and the rounded. So what you really want your calculator doing is getting you the rounded, the decimal name, so that you're going to be able to round. And you should be able to do the exact without the calculator. You need to know how to do that anyway. Okay, the next one. 2x squared plus 64 equals 0. What should we do? You gotta get the x squared term alone on one side, the constant on the other. Divide by 2.
Subtract 64.
Okay, let's start by subtracting 64. Let's do the first step, which says get the ax squared term set equal to the constant term. Now we could divide both sides by 2, right? So, and we could have done it in the beginning, it's okay, but we would have had to make sure that we did it to all 3 pieces, and I remember students not remembering to do it to all 3 pieces, so I was thinking that wasn't a very safe route. And we have x squared equals what?
32.
Negative divided by a positive is a negative. Next step,
Square root of
okay, square root of x squared, square root of negative 32. There should be some sort of flashing warning sign going off in your head saying, wait a minute,
some negatives.
it's a negative, so you can't take the square root. You can't find an exact order around it. So we're going to say no solution. And we're going to put in our notes why. Can't take square root of a negative. I think we put an exclamation point there. Oh, because we already tried it for negative 64, didn't we? And it didn't work, did it? Okay, so our answer for this one is no solution. Well, if there's no solution, we can't exact it or round it. Okay, one to go. What do you want to do? Subtract 125. Okay. I think we're going to be safe. The reason being because we're going to divide, right?
Yeah,
We're going to divide anyway, so maybe it'll work out okay. What's 25 take away 125? Negative 100. Okay. Now what would we do? Okay, now be careful. Do not stop here and say, oh, can't do this when there'd be no solution because I can't take square root of negative 100. Yeah, we're going to get rid of that negative 5 first, and then we're going to make that decision. So the first thing we have to do is get that, since the way we set it up, we need to first make sure that we've done everything we can do to it so that we have a positive x squared, a positive 1x squared. So this creates our positive 1x squared. And what's negative 100 divided by negative 5? 20. Well, we took care of our problem, didn't we? We have a positive number. So we're going to take the square root of both sides. And is 20 a perfect square?
No.
No. What's the first thing I'm going to write? No. Otherwise, we're going to forget it. Yep, otherwise we're going to forget it. Just get in the habit of right away. As soon as you take the square root of x squared and write x equals positive negative. And since 20 isn't a perfect square, we ask ourselves, can we, now, let me give you a little warning here. Not always can we find a perfect square that goes into the, what we call the 20, called the radicand. So, like 15. Would 15 have a perfect square factor?
No.
3, 5, no. So sometimes you can't, and this is where it would stop. You would say, okay, well then it's going to be a positive negative square root of 20, or in this case we can, but let's say it was the 15. It was positive negative square root of 15, we would leave it that and say there's its exact. I can't simplify it any more than that. But here, we can simplify this one. What perfect square goes into 20? 4. So we're going to change it to the square root of 4 times the square root of 5. Square root of 4 is 2. Does 5 have any perfect square factors? No. So there is the, what is this answer called?
Exact.
This is the exact simplified radical form 1. And now we do the approximate, which is really this same answer, same thing as above, the square root of 20. It's just, where is that actually at? Because right now, if I said to you, where is 2 times the square root of 5 on the number line? Would you know?
No.
No. That doesn't mean anything, does it? So we need to actually find the square root of 20 now, and we're going to round it to the nearest hundredth. And since some of you probably haven't figured out yet how to change your calculator to do that, I will do it for us and give you the first 3 decimal points after. So 4.472. 47 is 47 hundredths. 2 big enough to make it 48 hundredths?
No.
No. So we're going to say 4 and 47 hundredths is our rounded answer. How many solutions are there? 1, 2, 3, 4? No. No. Only 2. Only 2. 2 given in their exact format. 2 given, the same 2 given in their rounded answer, so we know where that would be. Now we can say, oh, it's gonna be somewhere between -4 and -5 on the left side of the y-axis. It's gonna be somewhere between +4 and +5 on the right side of the y-axis. So the rounded gives us a much better picture of where in the world would this parabola cross. So let's take a look at that. Let's see. Go to your graphing calculators one last time. And we're gonna have to put it in as, let's just do it like, let's bring this 25 over here. Let's put it in as 100 minus 5x squared. Let's put it into the graphing calculator that way. So go to y equals, put in 100 minus 5x squared, graph it. And does it appear to be,
Yes.
okay? So, go to the table. Get kind of around that area where x is equal to a -4 and -5. Do you see any y equals 0 there anywhere? No, you're not going to. Because why? Because we don't have exact integer x values as solutions, do we? So it's somewhere between there, okay? And when we go to x equals +4 and +5, you should see the same y values, because that's where our symmetry is going on again. And we should see that we have, so in one spot, we should be somewhere between 0, I don't know what it would be between exactly right now, but we should be able to see the symmetry between those solutions, okay? Okay, so again, when is it going to be feasible? When is it going to be useful to use the square root method? When
When
b
equals
equals 0. Okay, when b equals 0. There's one other time, and that would be when you have a perfect square trinomial. Because what's true about a perfect square trinomial? What's its renamed factor name? When you have a perfect square trinomial, I'm just going to throw one up here for you. If I have 0 equals 4x squared, plus 9 would be 3 times 2 is 6, this. That's a perfect square trinomial. So the square root of 4x squared is 2x. The square root of 9 is 3. 3 times 2 is 6. 6x doubled is 12x, right? So this is a perfect square trinomial. So both factors would start with 2x. Both would end with 3. Both would have subtraction. This could be written like this, right? 2x minus 3 squared. So if I have that, if I am going to use the square root method, 2x minus 3 squared, I would say I have the square root of 0. I have the square root of 2x minus 3 squared. Well, what's the square root of 0? 0. What's this, positive or negative? What's the square root of 2x minus 3? Squared. Okay, let me do this for you then. You're kind of giving me that deer in the headlight look. Are those the same thing?
Yeah.
And what's the square root of 9? 3. Well, what would the square root of 3 squared be? 3. Okay, so this is really the square root of 3 times 3 equals 3. So what's the square root of 2x minus 3? That binomial squared.
3 cubed.
Okay, let me write that the way it really looks. 2x minus 3, 2x minus 3. What's the square root of that? What times itself? Oh, I know that's tricky. I didn't make you do any of these in this lesson, but I want us to be aware of that. When you have a perfect square trinomial, you can also use the square root method because of the fact that it is a binomial times itself. But you don't have to do any of those in your homework, which is good news, right? Okay, let's get to work.